So the next question is question number 10, which was appeared in the 2014 NEET. The question is, the weight of silver, whose atomic weight is also given, displaced by a quantity of electricity which displaces 5600 ml of oxygen at STP will be. Very simple question, easy question. We can solve this question in two ways, in two methods. This question is based on the Faraday's laws. Firstly, I can solve this question in second law of Faraday by using second law of Faraday. And we can also solve this question with the basics of the Faraday's law by using first law of Faraday. Now the question is, I solved here according to the second law of Faraday. We know that we can write the equation like this: weight of silver by equivalent weight of silver is equal to volume of oxygen by volume of oxygen at STP. Now we know that volume of oxygen at STP for the flow of 1 Faraday of current, oxygen gas is always equal to 5600 cm3 or ml. That means volume of oxygen presently in the problem it is given 5600, and volume of oxygen at STP is also given, which value is known value 5600 cm3 at STP. This value is given. It is given. And this value we know, known value. This is known value, this value. Now weight of silver we need to find out, WAG weight of, by equivalent weight of silver, this value is known, equivalent weight of the silver is, weight of silver is 108 gram, this value is also known, which is equal to volume of oxygen. This value is given in the problem only, 5600 cm3 or ml, by equivalent weight of silver is 5600 cm3 itself, value is known value. Then this 2 will get cancelled, then you will get value 1 and just cross multiply, you will get this value, that is 108 gram is the value by using the second law of Faraday. Very simple formula to substitute, that's it. Or by a single method, the basics of Faraday's law says that when 1 Faraday of current flows, the volume of oxygen released is 5600 cm3. Or in the inverse, when you take, when 5600 cm3 of oxygen gas to release, the quantity of current used is 1 Faraday. That means in the numerical it is given 5600 cm3 of oxygen, the current requirement is 1 Faraday. And when 1 Faraday of current, then the 1 Faraday of current, if it is silver, in order to deposit the mass, when 1 Faraday of current flows, 108 gram of silver is deposited. The quantity of current usage for 5600 cm3 is 1 Faraday. The mass in order to deposit 108 gram of silver deposition, 1 Faraday of current is required. Here usage is 1 Faraday. Here usage for 1 Faraday of current, so much quantity of current mass is get deposited. And given atomic weight is 108 gram. Then equivalent weight is 108 by valency. Its valency is 1 plus 1, so by 1. So equivalent weight is also 108 gram. Then the answer is 108 gram. 108 gram. And the correct option is option D, 108 gram. So the next problem is question number 11. Problem number 11. At 25 degrees Celsius, the molar conductance of 0.1 molar aqueous solution of ammonium hydroxide is. 9.54 ohms per hour centimeter square per mole, and at infinite dilution its molar conductance, infinite dilution is lambda naught m at infinite dilution is given. The degree of ionization of ammonium hydroxide, degree of ionization means alpha value we need to find out here for the same concentration and the temperature, and given. So in aqueous solution molar conductance, that is lambda n, is given 9.54 Simon centimeter square per mole. 1 by O is also called as Simon. And at infinite dilution lambda naught m. So you can see here the values you can write. This is 9.54 Simon centimeter square per mole. And the another value at infinite dilution not indicates at infinite dilution, whose value is also given 238. Then same Simon centimeter square per mole. Now need to calculate degree of dissociation, that is alpha value. So alpha value can be calculated in this way: lambda m by lambda m naught. This is calculate direct formula to substitute. Then when we substitute this, almost 9.54 divided by 238 something, 238, whose value you may get around 0.04. So the value is 0.04. That is the alpha value. But the value is given in terms of degree of dissociation. That is, see here, it is given in terms of percentage. So percentage will multiply the value, obtained value, by using 100. That is, I can write 4.04 into 100, that is 4%. So option A. Well, question number 12, which appeared in the NEET 2013, very important question. A button cell. This question is based on batteries. A button cell used in the watch functions as follows. This is the reactions which taking place in the button cell, which we use in digital watches. Two half reactions given, one may be the oxidation, one may be the reduction. Whatever it is, we have to calculate the cell potential. To overall cell potential we need to find out. Then electron potential of both the cells are given. Zinc and electron potential of silver is given here. Both are given. Now we need to find out electron potential or cell potential. What will be the cell potential? It is a direct formula we use, and the formula is E naught cell is equal to E naught of RHE minus E naught of LHE. Let's write the reaction now. Now question number 12. Zinc, electron potential of zinc to zinc is given minus 0. Which value is given here? Minus 0.76 volt, and similarly electron potential of silver is also given. Electron potential of silver, standard electron potential of silver is also given, that is plus 0.34 volt. Now we need to find out E naught of cell is equal to what? E naught of cell is equal to what? So next, E naught of the cell, E naught cell is nothing but E naught of RHE minus E naught of LHE. E naught of RHE minus E naught of LHE. RHE must be higher value, LHE must be lower value. By looking at the values, that time only we can decide which one is RHE and which one is LHE, or which one is cathode, which one is anode. Look at these values. In between this value, this is bigger values, more value. That means it must be RHE. lesser value, that is less value, then it must be LHE. Then finally we substitute RHE is plus 0.34 minus half minus 0.76 volt, that is plus 1.1 volt, that is option is C. Question number 13, which appeared in the NEET 2013. Very important question, very beautiful question and interesting question. See the question. Now given is hydrogen gas electrode is made by dipping platinum wire solution of HCl whose pH is given. Very interesting question. pH value is given, okay? And by passing hydrogen gas around the platinum wire at 1 atm pressure, the oxidation potential of electrode will be. He is not asked the reduction potential, he is asking the oxidation potential. Oxidation potential, we know that. Now come on, let's solve the question. pH is given 10, then only so much is given. We need to calculate E oxidation. Oxidation potential, not reduction potential. Oxidation potential we need to find out is equal to what? We know that E reduction potential is equal to minus of E oxidation potential. This is the relation you should know. E of reduction potential must be equal to E of oxidation potential. Let's solve the question. E of cell is equal to E naught of cell minus 0.0591 by n log of molar concentration of hydrogen, that is 1 by H plus. How it is? Like half hydrogen gas undergo oxidation in presence of platinum to form H plus at waste plus an electron. To this I can write the Nernst equation, that is E is equal to E naught of cell or E naught of cell, better I can write hydrogen to reduction potential plus hydrogen minus 0.0591 by only one electron change, 1 log of molar concentration of hydrogen power 1, because number of hydrogen is 1. Now electrode potential of standard electrode potential of hydrogen, or you can write reverse also, no problem at all. Is equal to 0.0 volt. This value is known value. To substitute here, this value becomes 0.0 minus 0.0591. This I can write log H plus. Then when you invert it, when it goes here, this value becomes positive value. And we know that pH is equal to negative logarithm to the molar concentration of hydrogen ion. This formula we know. That means E cell or potential, electron potential first we are calculated, then we will go for the oxidation potential, is equal to minus 0.0591 into pH. Then E of not cell, it is only half cell, we are calculating the reduction potential. Reduction potential is equal to minus 0.0591 into 10. pH value is given here. Here it is given. Then E oxidation is equal to plus 0.59 volt is the final value. Why? Because E reduction potential of E minus oxidation potential. Then the correct answer is option D. That is the answer. Question number 14. Karnataka NEET 2013. It was earlier called as Karnataka CET, but it appeared in the same question was considered in the NEET also. Same marks were considered in the NEET. So, well, the coming question is question number 14. Which question was appeared in the Karnataka CET once again 2013? They are called as CET question, but question was considered in the NEET also. You can see the question, most beautiful question. You can observe here. The question is given: Mn2 plus takes electron, and in this reaction, during the reduction of Mn2 plus to Mn, its potential is given electron potential minus 1.1 volt. And in the second reaction, it is given Mn2 plus further get oxidizes to Mn3 plus, magnesium 3 plus, and its potential is also given minus 1.51 volt. These are the given data, and the finding data is this. When this is electron potential so much, when this is so much, then for this reaction is how much? That means the reaction with 3Mn2 plus gives you Mn plus 2Mn3 plus. What is the electron potential for this? And also one more question is added up there. And possibility of the forward reactions are forward reaction. For the forward reaction, E naught of the cell must be positive. Due to the spontaneous reaction, E naught must be positive. If E naught is positive, then only the reaction is possible. Now, by looking at the options, we can eliminate two improper options. See the option number A. Value is given minus something, minus 4 point something, and it is given yes. No. If it is negative, this should not take place. It must be no. So by looking at the option, option A will be removed. It is not the correct option. And when we go for option C also, it is given plus, and here it is given no. So the option B is given plus 0.33 volt, and it is given yes. Let's see. And option D is given minus 2.69 volt and no. Let's see, these two options are eliminated perfectly, and we will see which one is the correct option. Now the fight is in between B and D. Now come on, let's take this equation here. These values are given. These values are given. For this we need to find out. Then what we will going to do? Mn2 plus 3Mn2 plus gives you Mn. So 1 Mn is given here, and 1 Mn2 plus is already there. Then here it is given 1 Mn2 plus gives you 1 Mn3 plus. Now the number of Mn3 plus is 2. So that what I will going to change here only one thing. I will multiply this equation by using 2. When I multiply this equation by 2, this becomes 2, this becomes 2, and this also becomes 2. 2 electrons get cancelled on either side. But here one thing is important. Since electron potential is intensive property, intensive property means when you multiply with these two, this cannot be multiplied, does not depend on the amount. Whatever amount you use, the value does not depend on the amount. So it is intensive property, amount independent property. So that what I will do, I will add, when I add 2 Mn2 plus 1 Mn2 plus 3 Mn2 plus, then 1 Mn is written here, it gives charge is also 0, then 2Mn3 plus 2Mn3 plus is given. Finally, you just add. When you add, what will be the answer? We'll get the answer when you add this. Almost we'll get minus 2.69 volt. Minus 2.69 volt will be the answer. So the value comes in terms of negative, so that forward reaction is not possible. Option D. Option D. Cell will not work. Well, question number 15. Once again, question is based on Faraday's law. How many gram of cobalt metal will be deposited when a solution of cobalt 2 chloride, cobalt 2 charge of cobalt is 2 plus, is electrolyzed with a current of 10 amperes for 109 minutes, and atomic mass of cobalt is given, 1 Faraday value is also given. That question based on first law of Faraday. Now let's start this numerical by using how many gram of cobalt will be deposited. So cobalt, weight of cobalt is equal to dash gram. Is equal to dash gram. This we need to find out. Now what and all given, let's find out. Cobalt 2 chloride, that is cobalt 2 plus chloride, charge is 2 plus. This is required in order to find the equivalent weight. When electrolyzed with a current strength of 10 amperes, the current strength I is given 10 amp. And also given the time t is equal to 109 minutes. Now we need to find out weight of cobalt. Weight of cobalt and atomic weight of cobalt is also given, which is approximately 59 unit. 59 unit. Let's find out. First, before we calculate the mass, first convert this atomic weight into equivalent weight. So equivalent weight is equal to atomic weight by valency or charge. Now atomic weight is given 59 and valency factor is 2. Approximately we will get 29.5 equivalent weight. You can also take in terms of gram, it is given in terms of unit, you can take in terms of grams. Now we know that W gram and quantity of current W gram. In order to deposit one equivalent weight of cobalt, that is 29 gram, 29.5 gram, the quantity of current required is 1 Faraday, because 1 Faraday is nothing but 96,500. 96,500 coulombs is exactly equal to or equivalent to 29.5 gram of cobalt. Then, for this quantity of current, first law Faraday says that Q is equal to I into T. T must be in seconds. Then we can convert 109 into 60 seconds. Type 10 amperes. 109 into 60 seconds. The total comes in terms of, this is called as quantity of current coulomb. For 96,500 coulomb, 29.5 gram of cobalt is deposited. Then 96,500 coulombs of current will pass, 29.5 gram of cobalt is deposited. Then 10 into 109 into 60 coulombs total. We can simplify later. So don't simplify here again, don't simplify two times. Only one thing, single step only simplify. For so much, what quantity or amount of cobalt is deposited. That is, cobalt is equal to, so 10 into 109 into 60, 29.5, upon 96,500 coulomb. So during I simplified, after the simplification we can get the value, that is approximately 20 gram. You just calculate that, you will get 20 gram. So weight of cobalt is 20 gram, option B. Question number 16. A beautiful question based on the Coleridge law, very simple, direct question based on the Coleridge law and limiting molar conductivity. Limiting molar conductivity of ammonium hydroxide, that is lambda naught m of ammonium hydroxide, is equal to. It is a direct question. So for this question, ammonium hydroxide plus sodium chloride reacts to this product, that is ammonium hydroxide plus sodium chloride gives you ammonium chloride plus NaOH. That is, when you apply the Coleridge law for this type of equation, we can apply lambda naught m of ammonium hydroxide plus lambda naught m of sodium chloride is equal to lambda naught m of ammonium chloride plus lambda naught m of sodium hydroxide. So we have to calculate for ammonium hydroxide. You keep this side and you send that side. If you send it that side, then so much is same minus lambda, that is limiting molar conductivity of sodium chloride, minus it will come. So correct option is option D. Option D is correct option, where minus NaCl is option D. Question number 17. Just one NEET question, APMP question in fact. Standard reduction potential, SRP values are given for half reactions. Fluorine to fluoride plus 2.85 volt, chlorine to chloride plus 1.36 volt, bromine to bromide plus 1.06 volt, iodine to iodide plus 0.53 volt. Asking the strongest oxidizing and reducing agents. So please eliminate this. This is not there. 23 by miss, by maybe the typing was not proper. So 23 is not there. 2, 3 number you eliminate. This is not there. This is not there. So what I was asking, strongest oxidizing and reducing agent. I told you the condition for the strongest reducing agent. So strongest reducing agent. Reducing agent, strong reducing agent is always inversely proportional to E naught of metal, whose value is very low. Such type of substances behaves as strong reducing agents. So strongest reducing agent is one whose value is electrode potential is very small, and strong oxidizing agent is one whose electrode potential is more. Accordingly, just simplify these two. Remember, come here, and strong reducing agent should have very less value, and in out of all the 4 equations, the one which has very less value is this value, 0.53. So our reducing agent must be either iodine. You may get confused later whether it is iodine or iodide ion, and here the reducing agent is this one, iodide ion. Iodide ion is the best reducing agent. So iodide ion, where is iodide ion? Here iodide ion is there. Then next is given fluorine. And also I told you, strongest oxidizing agent is one whose electrode potential, standard electrode potential of the metal is more. And out of all 4 sets of equations, we can see here the one which has very high value is plus 2.85 volt. So this is the reaction where we can find the best oxidizing agent. And oxidizing agent which 0 to minus have greater potential to get reduced, but it oxidizes the opponent because of the high value. It easily get reduces but oxidizes the opponent. So because of this, the fluorine F2 is the best and strong oxidizing agent. Accordingly, the option A. Option A is the correct answer. Further, move on to the next question. Question number 18 in the NEET series. Question was appeared in the 2012. The question is again based on the Kohlrausch law, limiting molar conductivity. Applications of Kohlrausch law. The question is based. The question is molar conductivity not indicates infinitization. At infinitization, correct symbol is given of NaCl, HCl, sodium acetate values are given respectively. Lambda naught M for acetic acid will be, we need to find out. As we already discussed in the previous questions, how to write equation for this. The equation is something like this. Acetic acid, when it reacts with the sodium chloride, to form sodium acetate and HCl acid. To this, let's apply the Kohlrausch law. Lambda naught of acetic acid plus lambda naught of NaCl equals lambda naught of sodium acetate plus lambda naught of HCl. We need to find out for this. Keep this as it is, send it that side. Then lambda naught of acetic acid is equal to lambda naught of Na plus lambda naught of HCl plus minus lambda naught of NaCl. Then the obtained values just simplify. For NaCl the value is given. For NaCl, for sodium acetate it is 91.0 plus for HCl it is given 425.9 minus NaCl that is 126.4 and final value would be around 390 Simon meter square, centimeter square, Simon centimeter square, mole inverse per mole. So the option is option B. Question number 19. The Gibbs free energy for the decomposition of aluminum oxide at 500 degrees Celsius is as follows. This equation, decomposition of aluminum oxide taking place. Now 2/3 aluminum oxide gives you 4/3 aluminum. Delta G, Gibbs free energy change, is also given plus 906 kilojoules per mole. Now the potential difference, that means E naught we need to find out for the electrolytic reduction of aluminum oxide at 500 degrees is at least, so E naught is, we know that delta G naught is equal to minus NF E naught of cell. Now we need to find out NF E naught, so E naught of cell is equal to delta G naught minus by NF. Yes, delta G naught is already given, whose value is plus 96 kilojoule per mole, and the value N we need to find out. F value we know it is 96,500 coulomb. Now N value we need to find out. Let's write the equation. The equation is something like this. When aluminium, the charge of Al2O3, the charge of aluminium in the aluminum oxide is plus 3. When it containing one aluminium oxide, the charge must be 3 plus. For 1 aluminum oxide, the charge must be plus 3. For 1 aluminum oxide, the charge of aluminum must be 3 plus. Given is how much? 4 by 3. Then 4 by 3 of aluminum. 1 aluminum charge is plus 3. Then 4 by 3 aluminum, what is the charge? Once again, very simple classification, multiplication. So cross multiply, let it be the charge of aluminum. So let it be x, value x. So x is equal to, so this multiply 4 by 3 into 3. So 3 get cancelled, x is equal to plus 4. So the number of electron change is plus 4 or 4 electron change. Simplify this in this equation. Take this equation out. E naught of cell is equal to delta G naught. Look at this value is given in terms of kilojoules per mole. Please convert kilojoules into joules. That is 96,005. Delta G naught 960 into 10 power 3 upon 96,500 into 4. So what happens here? It is put point here, then one more zero cancel, then what is left? 10 by 4. Here one thing is minus value, it comes under minus value, but see, decomposition is taking place with given value itself is delta T naught plus 96 plus 96. It's supposed to be, if it is a spontaneous, it must be negative, but given is plus 960. In this equation, no signs are mentioned, only the complete numerical value you need to write down. Then obtained equation is 10 by 4, that is 2.5 volt. 2.5 volt. And the correct option is option C. Is the correct answer. The standard electrode potential of 3 metals are given. X is given, standard electrode potential of X is given minus 1.2 volt. Electrode potential of Y is given plus 0.5 volt, and electrode potential of Z is also given minus 3.0 volt. What is asking? Reducing power of these metals will be, then which one is the strongest reducing power? Which metal has the strongest reducing power? Strongest reducing power means it should have a minimum lower electrode potential. And which one has lower electrode potential? Lower electrode potential is Z. So Z, after that X, then Y. Z, X, Y. Z, X, Y. Option is C. Option is C. Option is C. Option C is correct.